Hello and welcome to Project 152, your weekly specialist exam preparation. If you stick with this all year, you'll know every single question that the QCAA has ever put out there. Alright, so this week is our week 2 solutions. So last week when I made this video, I said go to the description, there's 5 questions there, do those questions. This week, there's 5 new questions, go to the description, do those questions, and you'll be ready for next week's video. I hope that makes sense. If not, click the link in the description, it'll make sense. Alright, let's get started. This is our first question. Now, every question today is a tech active question. I'm going to be using the Casio. So, apologies to anyone who is a TI instruments kind of person. Casio is where I'm at. If everything that I can do, you will also be able to do, so just go and figure it out. So during these questions, we're going to make sure that we're using our calculator efficiently. That's our basic idea. Now, this is complex numbers, and we can just do this entire thing on our calculator. Here's how we do it. We click here, and we're going to start doing all that. I'm just going to get rid of all this. Okay, so from here, we're going to click our options button, and we're going to go complex numbers. All right, and there's a bunch of stuff we can do with complex numbers here. Now, our question is asking us, look over here, the real component of u to the 5 minus the magnitude of v, or the absolute value of v, however you want to say it. All right, so arrowing across, we can do this whole thing. The real component of, and what do we want? We want u to the 5. Now, u to the 5 is, I'm going to put this in brackets, 1 plus, and then I'm going to press this I, and then I'm going to raise that to the power of 5, and then I'm going to subtract the absolute value of negative 12 plus 5i. Okay, so is that right? Minus the absolute value of that. That looks good. We'll put that in brackets. You can see the colors line up. Execute that, and our answer is negative 17. Okay, let's see if we're right. Yes, we are. Now, I've typed that all into my calculator kind of mindlessly. I just followed the formula. You could do it in different ways. You could do like 1 plus I to the power of 5, figure out what that is. Do absolute V, figure out what that is. And then just look at the real component rather than ask your calculator. But like I said, I want to show you that your calculator can really do like all of that stuff. Some of you might not know that yet. Celebration and question 2. So we're looking for a vector normal to the plane that contains this vector and this vector. So you should be thinking, oh, normal to the plane, you should be thinking cross product. So we want, we've got a vector, 1, 3, 0. We've got another vector, 1, 0, 2. And we want to find this one that's perpendicular to both. We need to find the cross product of that one and that one. Calculator will do all of it. Now, I always get a little bit lost when it comes to matrices and vectors in here. So let's have a look. Options, mat VCT. Now this one here has like the matrix vector like operations. So I go in here, I look for it, here it is. The vector stuff comes at the end. Cross product. Okay, so we're going to put in our 2 vectors here. Now just exit out of there, okay, and go to math. Now this is kind of where you can enter mathematical symbols and stuff. So I'm going to go in here, and this one is where we can enter mathematical vectors and stuff. Okay, now for vectors, it's a little bit different to what you might be used to. We are looking for a 1 by 3. So instead of downwards, we work acrosswards. 1 by 3. And so our first one is 1, 3, 0. And then after that, we want a comma. And then our second one, also a 1 by 3. And we've done 1, 3, 0, so we need to do 1, arrow across, 0, arrow across 2. All right, and then we just got to close up the bracket for like the cross product thing. And enter. 6, negative 2, negative 3. So do I see a 6, negative 2, negative 3? Not A, not B, not C, but I do see D. Now, important to note, if you're doing like multiple choice question that looks exactly like this. There are a million vectors that are normal to a plane that contains these 2 vectors, right? Because what I could do is just make this green vector taller or shorter or in the other direction. So it just so happens that the exact cross product I calculated is the same cross product that like the QCAA people chose. But if I'd done it in the other direction, if I'd done 102 first and then 130, I wouldn't have got an answer of 6, -2, -3. I would have got an answer of -6, +2, +3. If the QCAA is feeling really tricky, they could just create any multiple of this vector and have it be the answer. So their option could have been 12, -4, -6, because that's just a longer version of the one I created. So just keep in mind when you're doing these sorts of questions, if it says a vector normal, it could be the one that you've calculated, but it could be like the reverse of it. It could be any multiple of it. Celebrate, next question. So here's our next question here. It is a dominance matrices question, and there's no way you're doing this by hand. You have to know how to enter this into your calculator. So we've got this matrix, and we want to do m plus m squared plus m cubed in our calculator. All right, so here we're going to go into the matvec thing, but totally different one to the previous ones we did. The first one we did, we found in the options. The other one we did, we found in the math. And this one is just sitting right here waiting for us. Watch what happens when we click this one. Boom. Okay, we get this weird little list of matrices, and I'm going to click enter on there, and I'm going to say a 5 by 5, and I'm going to click execute. All right, and then I am going to enter every single one of those numbers in and hopefully do it correctly. All right, so I've entered them all correctly. Now there is a saying in computer science, go, garbage in, garbage out. So if you make a single error here, you are going to get garbage out. All right, so once you've double checked, once you're happy with every single value, we are going to exit out of this screen. And you can see we've saved matrix A, and it is a 5 by 5 matrix. We're going to get out of there. Okay, where are we going to go to next? We're going to go to options, and this matvec, because this is the operations. This is where the magic happens. All right, so what do we want? We want mat, and then we need to find the capital letter A in amongst our stuff. So we go alpha, and then where's capital A? There it is. Now we're going to add to that. We've got mat A, alpha A, and then square that, right? So I'm just using the squared there. And then plus, and there we go, one more time. We're going to need some brackets. Mat A, alpha A, and then we're going to square it. No, we're not. We're going to cube it. Fingers crossed, all the syntax is correct. Enter, and that is our matrix. Now what's that matrix? That's m plus m squared plus m cubed. Now that's no good to us because we actually need to add up each row, and there is a very fast way to do that. And you know, it's the sort of thing that you need to practice or you might forget how to do it. So we are looking for the correct matvec thingamajig. So let's go to our options here, matvec, and we need to call that one that we just did. And we can just do that by going mat shift answer, right? What that's telling the matrix, the calculator, is that the answer was a matrix. If you don't write mat ants, it's not going to work, right? Okay, but then we're going to take that matrix and multiply it by a 5 by 1 matrix. So going to options, this matvec this time, my mistake, going to math, this matvec this time, and do this one, a 5 by 1, and just a group, just a bunch of ones. What this has the effect of doing is just adding up the rows. Done. 59, 61, 38, 97, and 37. So these values now are the scores that our people get. So the one in first place, the 97, that's S. The one in second place looks like 61, so that is Q. The one in third place is 59, so that's P. SQP. The last place getter is the last letter, which is T. And the other one is R. SQPRT. Let's see if we are correct. SQPRT. The answer is A. Now, obviously, you're going to want to be super fast with your calculator. This matrix stuff can take a little bit of time. This question should only take you 90 seconds, so you want to get real good. You're going to practice more than I do, so you're going to be great. Celebrate. Short response questions. Okay, so this is Leslie matrices, and we've got part A, 1 mark, part B, 1 mark, and part C, 3 marks. So if it's 1 mark, you don't have to show any working, you just make it happen, right? So part A, it says to state the initial population matrix. So population equals, so population at time 0, or population in year 1 is how they're stating it. 150, 101, 84, and 62. It's as simple as just writing in these numbers. There is our initial population matrix. There's a mark. Hello. All right, part B here. It says determine the Leslie matrix. All right, and this is the part where people are going to get confused about what bit goes where. Okay, so let's make sure that we're all on the same page. You can see that there are 4 population things. So your matrix is going to be 4 across and 4 down. Now, the 4 across have to relate to these birth rates. 1, 2, 3, 4. I'll give you a way to remember that in a second, and a way to sort of make sure that you haven't made the mistake here. So birth rates along the top, and 0.1. So 4 birth rate. And then we're going to start from here and go diagonally down with the survival rates. So we're going to go 0.6, survival rate 0.3, 0.2. Right, now I've gone diagonally down. It is a 4x4 matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0. Hopefully that makes sense. Maybe that's a little better. Now, I said I was going to explain to you like how to make sure you don't confuse these. Your survival rates, you always have 1 less survival rate than you have birth rates, right? The survival rates go diagonally along here. You're going to have 3 of those because in all of the questions I've ever seen, you end up with a 0 survival rate in that last year group. Your birth rates all the way along the top. You're going to have 4 of those, and you're going to have 3 survival rates. If you do it in reverse, it's not going to work. You're going to end up with 1 too many diagonal bits and 1 too few across the top. Hope that makes sense. So that's part B done. You get 1 mark because you did that. And now we have part C. All right, so I'm going to do part C way up here. Now, this question is ambiguously worded, and the QCAA was aware of that. So when they marked it, they allowed a range of answers. Now, why do I say it's ambiguously worded? It says that this is the population in the first year. What does that mean? Does that mean at the beginning of the year? Does that mean at the end of the year? And then it says, will the population fall to less than 125 in the next 20 years? So we're somewhere in year 1, and then we've got to be somewhere by the end of year 20, in year start of year 20. So not as clear. I'm sure that in the future it'll be like at time 0 or at the beginning of the year and by the end of the 20th year, things like that. So a range of answers were accepted by the QCAA. So I'll show you what I mean by that in a second. Okay, so how do we figure this out? We've got the Leslie matrix to the power of something. Now, I think it probably makes sense to do like the Leslie matrix to the power of 19, because we're in year 1, we want to do the next 20 years. So I'm going to do L to the 19. That'll take me into year 20. I hope that makes sense, because I'm in year 1 here. So if I multiply it by this, I'll be in year 2. So that's L to the 1. Okay, but you don't always have to do that. The QCAA accepted L to the 20. They even accepted L to the 21. They accepted L to the 18. They accepted all sorts of values here because this was ambiguously worded. Okay, L to the 19 times the population matrix. So definitely a job for our calculator here. there's a variety of ways you can do it. Again, I'm going to go math, and I'm just going to put them in by hand. So I've got a 4x4 matrix, right? Okay, and I'm just going to enter those values. And I'm going to raise that to the power of 19. And I'm going to multiply it by, and this time it's going to be a 4x1 matrix. And enter those values in there. Now, when you do that, you're going to get these values right here. I'm just going to write them down and get rid of the calculator. So those are our values in each of the year levels. Now, it is a good idea to ask your teacher what they would like in IA2. Would they like you, if you're trying to find a total population, which was what I'm trying to do here, would they like you to add up all those values and round at the end? Or would they like you to round this value, round this value, round this value, round this value, and then add together? Now, the QCAA doesn't care, but your teacher might, so talk to them, ask them. Now, what camp am I in? I'm the camp that you should just add those together and round at the end. So I have 117.65. So the approximate population after 20, or within 20 years, however you want to look at it, is approximately 118. Now, if you've used a different power, 20, it'll be less. If you've used 21, it'll be less again. I'll defend my position for a second. Leslie matrices are predicting the future. They're estimates, not exact values. So if I want the best estimate of the total population, I should use decimals in those buckets because they're all estimates, and then take that value and just do that one. I think I'm adding unnecessary errors if I round each of those, but your teacher could have a different opinion. Debate me in the comments. All right, I think we're done. Oh, no, we're not. We're not. Determine whether the species of tree frog is considered to be endangered. All right, so here's a little thing that you want to do. 118 is less than 125, therefore endangered. Okay, so doing this shows you know what you're doing. You're communicating your work. You're showing I compared this number to this number and I've made a decision. It's kind of an important idea. I think I can celebrate. And one last question. And here's our last question. I think a relatively straightforward one, but it does give us a chance to talk about a couple more calculated things, etc. We have two position vectors, P and Q, this and this, and we're going to determine the angle POQ. Now, to me, this is just year 11 work, really. Your teacher probably hasn't spent a lot of time talking about finding angles between vectors in year 12, because you really did it in year 11. The only difference here is that these vectors are in 3 dimensions, and you probably only used 2-dimensional vectors in year 11. But all the same rules apply. And of course, those rules are sitting on your formula sheet. And there we are. And you should be thinking dot product. If someone says angle between 2 vectors, you should think straight away dot product. Okay, so why does the dot product, why is it so good at this? It's because there's 2 formulas for the dot product, and one of those formulas has the angle between the 2 vectors in it. So doing this is going to be as simple as writing magnitude A, magnitude B, cos the angle between the 2 vectors. I don't know why I've written this here. Okay, that's our first formula. And our second formula is just multiplying is just the dot product of A and B. I guess the more formal way of doing it, or the more familiar way of doing it, multiplying all the I components, the J components, and the K components. All right, so how much of this can we do on our calculator? Let's find out. So we want to know the magnitude of A. That's something we want to know. Let's find our... All right, so we can enter A, and when we enter vectors, we enter them as 1x3s or 1x2s, depending on what they look like. All right, so we've got A, which is, I guess it's P, right? Okay, so P is 2, it's -3, and it's 1. So that's P. And then we want to do an operation on it. So I go to my options, my matrix operations. Now, what do I want? It's not a word that you might think of. It is this norm here. the norm of this vector. Now I've arrowed to the front so I can do the norm of it, and then I've bracketed it. Okay, and you can double check that and make sure that it's right, but it's right. So the magnitude of P is root 14. What about the magnitude of Q? Now, of course, I can make my life easier just by jumping in here and going again. I have 2 root 6 there, cos theta. And then I have this P dot Q. Now we want to do a dot product. We want to do an operation. So I'll find that in options. Where are you? Dot product. There we are. Dot product. And then I've got to enter in my 2 vectors. So to do that, I'm going to come back to here in the math section and enter them here with the 1/3. And I'll need 2 1/3s. So let's put another one there. Close up the bracket. And then we're just putting our numbers in. 2, -3, 1, and 2, 2, -4. All right, and we get a dot product of -6. Isn't the calculator neat? Okay, so after this, we're just rearranging this. So theta is going to be equal to -6 divided by that, root 14 times 2 root 6. But inverse cos of that. So I typed it into my calculator and I get an answer of 1.9, which is obviously a little bit troubling, doesn't feel right. And then I glance up here and I see I am in radians. So let's see what happens if we change our answer to degrees. 109.1. Now that really is the end here. I'm done. Now I actually just double checked the QCAA's solutions to this. They actually give an answer of 1.9 here, as in 1.9 radians, which is what our calculator spat out the first time. So either degrees or radians, you're going to get the answer here. And this is about the working they showed. If you're looking at this thing, oh, I'm not showing much working because I'm doing so much on my calculator. Tech active. That's kind of expected. All right, so that was part A. We'll do a small celebration for that. We'll take a look at part B, get rid of this. So part B, super straightforward question. We're finding the area of the triangle POQ, right? So O is the origin. So there is a vector from O to P, which is 2, -3, 1. And there is a vector from O to Q, which is 2, 2, -4. Okay, and we're trying to find this area in here. And you should know straight away there is a formula for this. It is equal to the area is equal to half of the magnitude of the cross product of vector P, vector Q. Although I guess I should probably be a little more pedantic here. This is point O, this is point P, and this is point Q. So it's really OP and OQ. So are we going to do the whole thing on our calculator? Yep, pretty much. Now I'm going to do it sort of a little bit step by step because I don't want to try to do the whole thing all in one go and mess it up. So I'm going to go options and then matvec because that's going to give me all my different calculations. I'm going to do the cross product first, this bit in the middle. So cross product, and then I have to go out of this into math and where I can enter my vectors. And it's 1/3. And I'm going to enter the first one, 2, -3, 1. And I'm going to enter, I need a comma. And then I'm going to enter my second one, which is 2, 2, -4. And then I close that blue bracket up. All right, interesting. The cross product is 10, 10, 10. Okay, so what do I need now? I need the absolute value of 10, 10, 10. So I'm doing another matrix calculation. So I'm going to go into option matvec all the way to the end, and I'm going to do the norm of, and then I want to use my answer. So I'm going to go across again, mat shift the answer. All right, so I get 10 root 3. And then I want half of 10 root 3. And, you know, I probably don't need a calculator to do that. 0.5 times the answer. I get 5√3. Determine the area of triangle POQ, 5√3 units squared. What's that as a decimal? 8.66. Okay, that's the ball game. You can see I've gotten 2 marks. I've barely put much ink on the page. This is tech active, just enough to show that you know what you're doing, and then you're putting things into your calculator and getting answers spitting out. And I think we need one of these. Well, that's it. That's the end. That's week 2 solutions. Now, hopefully you got the theme of today's video, which is in a tech active exam, you've got to be using your calculator to its full abilities. Otherwise, you're going to run out of time. To be able to do that, you've got to be fluent at using your calculator. If you're getting lost, if you're not sure where the buttons are, you're going to have problems. You will get better as long as you keep practicing it. If your calculator is still intimidating you, it's time to get over that fear and get the hang of it and just embrace that it's part of you. Okay, go down to the description. There's 5 new questions there. I've made sure I've put a more difficult one at the end because I think you probably need something just like a bit more meatier after those questions. I don't think they were too hard. Tech free. Okay, catch you next week.